This podcast is going to talk about thiols, which is one of my favorite functional groups and families, but we don't get a chance to talk about this too much beyond the next couple of podcasts. So a thiol has an SH or a sulfohydryl group as its functional group. So if you see an SH or a sulfohydryl on a molecule, you can circle that and identify it as having a thiol present. In structures, sulfohydryl groups kind of function similar to hydroxyl groups. Your sulfur has 6 valence electrons. It's able to make 2 bonds, therefore, just like hydroxyl would, and you wind up with a bent shape around the sulfur, again, similar to what a hydroxyl would look like in a molecule. All right, as we just said, thiols are a group of organic compounds. They have that SH group in it, which is called a sulfohydryl. So you would refer to the sulfohydryl as being the functional group present. You would refer to a thiol as being the family it belongs to. As we said before too, they're very similar to alcohols when you're looking at the structure and the number of bonds that they're able to form. However, because they have a sulfohydryl group instead of a hydroxyl group, they're not going to have as strong of intermolecular forces between thiols because you don't have the presence of hydrogen bonding. So therefore, you have lower melting and boiling points. Oh, that's a terrible drawing. You're never going to see this because I just erased it. Okay, so here's our sulfohydryl group. It's attached to whatever chain of carbons. So when we're looking at this particular bond, we're looking at a difference in electronegativity. Sulfur is more electronegative than hydrogen, so it's going to pull those shared electrons closer to the sulfur and further from the hydrogen, which produces a dipole moment. So because we have a polar bond, we have a dipole moment, we have a slight negative charge on our sulfur. It is soluble in water, and it's going to have a higher boiling point than, say, an alkane, something with all nonpolar bonds, but it's not as strong as, say, a hydroxyl group, because the hydroxyl group has hydrogen bonding, and that is a stronger intermolecular force between two alcohol molecules. So it does have lower boiling and melting points. What is fun about our thiols is that they're responsible for some really stinky stuff. So a lot of the strong odors of garlic and onions and skunk and beer that's gone bad are a result of thiols. Right, so as we said, thiols are responsible for a lot of pungent odors and strong odors. Grapefruit is a good example of this. The odor of grapefruit comes from a mercaptan. Here we can see on the bottom there's your sulfohydryl group. My pen's not writing. I can't draw. Okay, switching pens. So we see the sulfohydryl group on there. Very strong odors from grapefruit. Obviously, I've already told you that skunks have thiols in that spray that they emit. The spray that they emit has 3-methyl 1-butane thiol in it, and that is partially responsible for the stench of thiols. But I do think thiols get a bad rap. Do keep in mind that some of the most wonderful IPA beers, the flavor and the aromas are only possible through thiols that are in the hops. So good things can come from it as well. All right, so we're not going to talk much about disulfides, but I did want to mention what a disulfide is. So this sulfur bonded to a sulfur is a disulfide, and it's very similar to ethers, except for it includes this 2 sulfurs instead of an oxygen. And so your hair has a lot of, these are called disulfide bridges that are going to hold your protein chains in your hair together. So if you had straight hair and you reduced it, you will break the sulfur-sulfur bond and you will get sulfohydryls as a result. What you can do with that hair then is to wrap it around curlers, oxidize it, so you're going to reverse what you just did, reforming those disulfide bonds. And essentially what you're doing is you're taking straight hair, breaking the bonds that are holding them straight, and then curling them and reforming the bonds so that you wind up with curly hair. So this is how we perm hair. So that's a great application of reduction and oxidation in beauty.